All right, gang, STAT 1800, more on the final exam study guide. In this video, I will do problems 11 through 15, so let's go for it. All right, problem number 11. Okay, so the table below contains the overall miles per gallon of the type of a type of vehicle. Complete parts A and B. So we want to construct, I'm going to go ahead and write this down over here. We want to construct a 99% confidence interval. Now, guys, notice that, I don't know why these numbers are in there. Well, I should have left them there. Maybe they're right. Wouldn't that be cool if you're doing your exam and you look up and the numbers are already there? I would still check it out. But anyway, guys, notice that the population standard deviation isn't given. So when we do our 99% confidence interval, so guys, I'm going to open this up in Statcrunch, and I'm going to go to Stat, T-Stat, again because the population standard deviation isn't given, one with data. All right, so I'm going to select this. I'm going to come down and do confidence interval, do a 99%, and hit compute. So if I remember correctly, I want this to go to one place, so that's going to be 27.4 to 34.8. I don't think the numbers were right before, so 27.4 to 34.8. So there's a 0.99 probability that the miles per gallon for this interval contains the average miles per gallon for this this particular vehicle. All right, and you can imagine why there would be variation. You know, driving conditions, average speed, driver. So choose the correct. So 99% of the sample data falls in the limits. Well, that's goofy because this is an estimate. We have a 99% confident that the mean miles per gallon is contained in the interval. That the population is contained, population mean. Now let's go through this in A is just wrong. 99% of the sample data. That makes no sense whatsoever. B is also wrong because it references the mean of the sample. Well, guys, we know the mean of the sample is contained in this interval because the mean of the sample was used to construct the interval. Because remember, you take the sample mean and then you add margin of error and then subtract margin of error to get the 27.4 and the 34.8. So B doesn't make any sense either. D, the mean miles per gallon of this type of vehicle for 99, that's not what it does. A confidence interval estimates the population mean miles per gallon, in this case for this type of car. So we know that that's going to be the answer. All right, question number 12. Use Statcrunch to determine the upper tail probability. So the first one, we have 1 minus alpha is equal to 0.95, and we have n is equal to 67. So we want the upper tail probability. So that means that our alpha is 0.05, so the upper tail alpha is going to be 0.025. All right, so let's go to Stat, Calculator, and go to the T. So we want the upper tail. So our degrees of freedom is 1 minus our sample size, which in this case is 66. We want the upper tail, and we want this to be half of our alpha. So 1.9966. 1.9966. Let me just double check that. I want to make sure I didn't look any further. 66. Now it wants us to do the upper tail probability if 1 minus alpha is 0.99. Now guys, again, let's think about that. That 1 minus alpha equals 0.99. Well, if I take the alpha across and take the 0.99 across, I get that alpha is equal to 0.01. So that is the area that goes in the upper tail and the lower tail. So we have to divide this by 2 to find this upper tail probability. So I need 0.005 in the upper tail. And that would be 2.6524. 2.6524. All right, question 13. The following set of data come from a sample size of 5. We need the mean, the median, and the mode, the range, the variance. So let's just, I'm going to write down the things that we need. So I'm going to do the first, the mean, median, and mode. First go through. So again, check that first row, make sure it's a number. Stat, summary stats column. So I want the mean, the median, and the mode. So 6, 6, and no mode. So the mean is 6. The median is 6. And there is no mode. All right, now we need the range, the variance, the standard deviation, and the coefficient of variation. And these need to go to essentially to 2 places, and then they want 2 places on the coefficient of variation. So let's do it. So stat, summary stat column. Let me make sure something, yeah. So what do I need? I need the variance, standard deviation, the range, and the coefficient of variation. All right. So the range was 7. The variance is 7.5. Says to go to 2 places, so I'm just going to go 7.50. Wait a minute, the variance, I got that in the wrong place. It's kind of confusing. 7.50. The standard deviation is 2.74. And the coefficient of variation is 46%. All right, compute the z-score. Well, guys, the z-score is just the data value minus the mean over the standard deviation. So I'm going to go back. So we want the again. Let's just write this down. So I want for 4 and 6. And our mean was equal to 6. And our standard deviation was equal to 2.74. All right, so guys, if I go back over here, I've written this down. So to find for 4, the z-value is going to be 4 minus the mean over the 2.74. So negative 0.73. And for 6, z-score would be equal to 0. Are there any outliers? Well, to find outliers, what we would want to do is we want to construct a box plot. Use fences to identify outliers, and we can see there are no outliers. What is the shape of the data set? Well, guys, let's compare the mean and the median. The mean and the median are the same, so we have a symmetric distribution. It's going to be a miracle if I don't have a typo or something in here. So coefficient of variation, let's make sure 46%. Okay, what did it tell us around to? Okay, 2 decimal places, so it got me on a technicality there. So that would be 45.64%. All right, I got sloppy again. That's the reason that I must hand grade these things after. Because if you put 46% there, because this is type an integer, so I didn't go ahead and read that, then I think you should deserve full credit. All right, question 14. 19A telecommunications company wants to estimate the proportion of households that would purchase an additional telephone line if made available at substantially reduced installation cost. Data are collected from a random sample of 500 households. So guys, we know that we have n is equal to 500. The results indicate 140, so x would be equal to 140 would purchase. Compute complete parts A and B. So we want a 95% confidence interval. So gang, what we would do here is we would go to stat, we would go to proportion stat, one sample, and width summary. So the number of successes would be 140, the number of observations would be 500, and we want a confidence interval of 95%. So it looks like we have, again, let's not get caught up on a little technicality here, round to 4 decimal places as needed. So we have 0.2406. And the right bound will be 0.3194. Okay, how would a manager in charge of promotional programs concerning residential customers use the result? Well, we have a 0.95 probability that the total number of customers will be somewhere between 24 and about 32%. So so can infer 95% confidence that the population proportion is somewhere in this interval. That the proportions, so guys, again, we're making a statement about a population proportion, so that's the only one that makes sense. All right, gang, one more question, right? That's what we were doing, 11 through 15? Yeah. All right, a manufacturer of chocolate candies uses machines to package candies as they move along a filling line. Although the packages are labeled as 8 ounces, the company wants the package to contain a mean of 8.17, so that virtually none of the packages contain less than 8 ounces. That makes total sense. A sample of 50 packages is selected periodically. The packaging process is stopped if there is evidence that the mean amount packaged is different than 8.17. So in a particular sample of 50, the mean amount dispensed is 8.161 with a standard deviation of 0.051. Now, since the standard deviation is known as the sample, we're going to use a t-test here. Okay, so we want equal to 8.17. And we want to make sure it's not equal to 8.17. Identify the critical value. So guys, what we've got going on here is we have a 0.05 level of significance. So our t-distribution is going to have degrees of freedom 49, right? And we want the rejection regions in the upper tail and lower tail. We're testing, I think, at 0.05. Yeah, 0.05 level of significance. So we want 0.05 total to be in each of these tails. So we need half of that there and half of it there. So really, guys, if we can just tap into that 1, we know that this is the plus and this is the minus, because the mean of the t-distribution is equal to 0. So again, degrees of freedom is equal to 49. So gang, what I need to do here is I need to go to stat calculator, and I need the upper tail. To be 0.025. So 2.009575.2. I'm just going to write it all out, that way when I get there, I'm not going to get caught on a technicality again. So identify the critical values to 4 places as needed. So negative 2.0096 and 2.0096. Determine the test statistic. Well, gang, I'm going to use the Statcrunch here. So I'm going to go stat, t-stat, 1 sample with data. No, with summary. So my sample mean was 8.161. My sample standard deviation was 0.051. And my sample size was 50. And I want mean equal to, gang, I forgot, what was it? 8.17? And not equal to 8.17. So my test statistic is negative 1.25. Well, it wants us to go to 4 places. That's pretty annoying, isn't it? So negative 1.2478. State the conclusion. Well, when we look at our p-value is higher than 0.05, so we fail to reject. So do not reject. There is insufficient evidence to conclude. So it looks like the filling line, the machine that's actually packaging the candies, is doing what they want it to do. Okay, determine the p-value. I thought we were done. The p-value is 0.218. So round to 4 places. Interpret the meaning of the p-value. So the p-value is just the, if the null hypothesis is true, it's the probability of attaining a sample mean as extreme as the one that we... So the p-value is the probability of obtaining a sample mean that is equal to or more extreme than 0.09 ounces away. The p-value is the probability of attaining a sample mean that is equal to or more extreme than 0.09 if the hypothesis is false. So guys, all of these, again, the p-value is under the assumption that the null hypothesis is true. And you can see that the only statement that gives the condition of the null hypothesis being true is in A. So that's the only one that it could be. All right. Looks like we are done with this video. Take care.